They had presented it in English. Well, I have signed myself up for this talk, and I'm really quite curious to see if we'll have English comments today. It actually states that we're going to do it in German. It actually says that right there in the description, but
Yes, the DAX is already English anyway.
But I've actually noticed now that an II or die podcast even includes an English audio track. So upon its release, with the newest one that came out today, you can also select an English audio track. I don't know which AI did the translation or under what circumstances.
yes, there are YouTubers who do that. We are actually live. Well, but then we would have to take a look. Perhaps it's possible that it's somehow rolled out channel by channel. I had also seen it before.
Yeah, I took a brief look this morning. From what I could tell, it seemed at least I did a quick search, a bit of Googling, and in the Google sphere, it appeared that you could, at the very least, supply your own audio tracks. But then
I've done that before, but it's a lot of effort and the benefit isn't worth it.
however, as it seemed, Ulrich had observed that there was a record somewhere showing it was done systematically. So apparently it was as if Google itself had done it once again.
Okay, well, it's definitely the case that thanks to Microsoft, because we're doing this as part of Data Days, as part of Data Days, we've received 87 registrations, which is something we've never had for Tinker's Talk. How many will actually show up? That's another matter. At least I see that there are already a few here. Pause. And so, hello and welcome, everyone. Pause. For those of you who are only here for the QR code for the free certification, we'll definitely help you with that, won't we, Marcus? Pause. Please show your screen.
Yes, please share your screen exactly. Just a brief explanation for a moment. Fabricator Days is currently an event that Microsoft is running, and we took the opportunity to include our meeting as part of that initiative and were then promoted accordingly. Accordingly, you now have 50 days to acquire knowledge, and you can check all the schedules under Fabric Data Days or aka.ms. You can see what sessions are available. Ours is also listed there, and you can really advance your knowledge. And if you want, you can also put that knowledge to the test. For this, there are vouchers available again. So if you wish to, you must request the voucher here. It's probably for a limited time and a limited quantity is available. But then you can also take a certification exam for 600 or 700. I believe we have exactly that for each. You got 700, I got 600. We'll see. Perhaps we'll eventually find time to do the others too.
Yes, I actually put them off. I had planned to do them in November, but then for personal reasons I couldn't. So then you have to spontaneously do training sessions, which I normally...
But you can do it, right?
Yes.
But you can do it. One can talk about how much it truly affects them personally in their daily work or not. It can be said that people who have completed the certification perhaps still have some gaps in their knowledge. At the same time, there are people who are highly specialized in certain subject areas and still don't pass the exam. But it's still worthwhile to expand your horizons and to delve a bit into some learning and definitely take an exam like this. And now, for free, there's even the chance to do it without any expense.
That's why, Andrea. She'll definitely pass spontaneously. Yes, Andreas, that must be for sure.
I still have another part to mention because...
I hope you diligently scanned the codes, so if you want to see it again, you'll have to stay until the very end.
Exactly.
Let's see if the numbers will now plummet after everyone has screenshotted the QR code.
You can always go back in the recording or let it play. Yeah, I'll watch it again later.
Exactly. If anyone is listening to this in English and does not understand German, just subscribe the Daten-WG channel and drop some comments. We can take that into account and re-upload it if you want.
Please feel free to text me since pause exactly. And for this Fabric Data Day, we've decided to I'll briefly revisit the topic of modeling. With this point, we've concluded today's broadcast, and you'll be showing something else very soon. But I just wanted to briefly bring up a few introductory points because all of this has really grown and developed with us, as is always the case, to include. And an important aspect, which I believe we should always briefly highlight, is this Power BI spectrum here, which you also somewhat introduced with the self-service axis, meaning that up front we have the business department heavily involved, which then performs its analysis using specific tools or methods. And then maybe there's for mid-sized businesses or for smaller companies a certain gap. And in the long run, we have the possibilities that have been around for a long time, because BI has been on the market for God knows how long, that you simply have an IT department or someone who can deal with it, more specialized and processed, and has already employed these tools. But historically, there was often a small gap in the middle, and we actually have a kind of growth curve regarding the scope of the individual topics. And what I wanted to look at a bit more from the development process is that we actually have 2 points. First, at the top, we have our analysis, and at the bottom, we have some data sources or raw data. And the main question is how we get all of that into our analysis. And I believe that's already a bit the first point regarding data modeling that comes up. Often many people think bottom up, which I'm not really a fan of, but they might have already received a table or some kind of data extract, and then they consider what analysis they can actually draw from it, what they can make and evaluate from it. However, we actually tend to prefer a more top-down approach. What this means is that you essentially want to proceed by saying, all right, we aim to change something, we aim to measure something, and we aim to control something. What information do we actually need to conduct our corresponding analysis? And upon which data or structures can we then build and integrate all of this? Here in the intermediate layer, that is exactly the point nowadays. If you start relatively simply with Power BI, you would have had the source down below and up above, the analysis tool Power BI, and then you could start the analysis. That's fine. It can be done to a certain extent. But what's increasingly being added now is, and that's what large enterprise solutions have always been doing, they've built up a data platform for themselves, and they've probably built some kind of intermediate layers in between. We're very flexible there, aren't we? I don't want to push that too hard right now, but these days we talk a lot about this metal architecture, bronze, silver, gold. But you could also say we have data, design, staging, we've set up core, and on top of that we've set up corresponding data marts through which we've made the data available to end users. This means the source has moved further down. In the meantime, we had the professional data preparation, and we also already performed modeling, data modeling at that point, and then we utilized it within our Power BI or our analysis tool. What you can observe here now is that the data modeling for the analysis is indeed within my Power BI tool. If I manage to insert a data platform at some point, then the corresponding data modeling also moves downwards. I just briefly interjected this here because it's something that already exists. Data Vault, for example, is also one such modeling method. Ultimately, what goes into the core, I haven't defined here yet, and it might not even be the right approach. But if you look at Data Vault modeling, for example, you also have a staging, a raw vault, build a business vault from that with business logic, and perhaps supply corresponding marts here. And from the perspective of its modeling form, this Data Vault architecture already provides structure. One way to initially pre-model data specifically into an architecture where you can say, okay, I have these various hubs which hold my corresponding business keys. Then I have links through which the different business keys are interconnected via certain transactions. And I have the satellites which then contain additional information. And this would be, for example, one way to model a kind of middle layer or a core. In data modeling, there's a great deal involved, and that's what's perhaps a bit more enterprisey on one end of the spectrum. What we already know from our Power BI days is the ROCHE'S maxim, which essentially means we try to push all these transformation steps as far back towards the source as possible. This also means that if our upstream system can already provide us with pre-prepared data, then we accept that and don't have to model it ourselves in Power BI. If I've implemented a data platform in between, I would actually want most of the transformations to happen within that data platform, pushed down as far as possible, so that within my Power BI data model, I can then consume the data, ideally already pre-processed and ready to use. A topic, and we'll continue with that right away. I'll try to go through it as quickly as possible. Oh, what we actually have, yes, I have to do it, is Michael with us?
No, Michael would have already dropped out much earlier at Data Vault at the latest, but probably already during the discussion about the certification. That would have been a much more entertaining session.
Yes, I'd like to address some terminology now. So sometimes you have to maintain a certain composure and implement best practices. For example, a star schema is what we predominantly favor. The idea is that we place the key performance indicators right in the center within a fact table. A fact table is indeed the technical term for this concept. Alternatively, it can also be referred to as a transaction data table. And around this, we built relevant objects, tables, and dimensions for analyzing these key figures. The advantage is that we can then equip these objects with attributes, additional information, extra columns, enabling different aggregation levels. And the other great advantage is that you can simply reuse everything. And there are also the topics of naming conventions. You should consider them when reusing, and that helps a lot to recognize and use these objects effectively. What's really important about our approach, even when it comes to Power BI, is that often less is more. So we'd prefer to focus on the requirement and ensure we fulfill it properly, and not always load all data at once, because that naturally down the line currently can cause performance issues simply due to the volume or the number of transformations that one has to perform, or simply storage space, which then might require expensive licenses. We often like to create a central date table, which we use to model time-based logic. A topic that can also be handled well here is role-playing dimension. This means if I have an object that can assume multiple states, I'll take the customer as an example here. If there's a delivery customer, an invoice customer, and an order customer, you could use this customer object multiple times, defining its specific role or integrating it into this model. However, you would only need to pre-model the customer data once and then be able to utilize it repeatedly. Here, regarding the date table, I wanted to bring up this reminder again, which we often make. I think we also discussed this back then at the offsite, that you can potentially make the data a bit more abstract, meaning if I have any planned values, monthly figures, I could, for example, assign them to the first of the month, or if I have corresponding annual values, then I can also set them to January 1st or to the last day of the year. It's essentially a workaround I quite like, to avoid making the modeling overly complex, but rather to find a simple element where I can place the data, and which then fits in a way that allows me to use it for analysis. Explicit measures are simply one of those essential tips that you really should implement. In the past, it was frequently the main topic to make sure that these key performance indicators were also accessible to external tools, and simply to guarantee that the appropriate calculation was always available. I believe, especially when we're talking about modeling, I believe many still like to, when they have a numeric column, just drag it into the Power BI report and to have the implicit measure generated that is to sum it up. I believe Excel now also supports this this function, but it still makes sense to to define certain key figures, even if the calculations increase, as explicit measures, and then also to provide them with formatting and additional information. Let's move on to our main debate, which is becoming increasingly relevant nowadays, and why we also quite like to talk about data modeling. This is, of course, the flat table or the one big table concept. You've already created several posts on this topic, and with them, you've certainly sparked some controversies or indeed created a considerable need for discussion.
I managed to get Martin on camera here.
Yeah, you see, that's right. That's why we'll be discussing that in more detail shortly. We also have the big announcement coming up, where we're still looking for an opponent for you, someone who is a complete fan of the one big table and challenges you with a suitable, not Greg, maybe in the German-speaking region.
That was a pretty nice comment.
He might yet come.
Just drop by for a special.
My approach here is this: we don't want to operate under the motto of see no evil, hear no evil, speak no evil. But of course, we should examine the entire issue, and we must always investigate where this particular situation truly originates. Often, I would say more towards the front of our spectrum that we've looked at this BI spectrum, where we're looking for a simple databases for perhaps an Excel pivot table, where the focus isn't yet so much on reusability, where the data volume might not yet be that large that one wants to use there, where one wants a certain overview.
Wants to have this wide table.
To put it in perspective, because a truly hardcore Databricks heavy organization, for example, already pre-calculates many different scenarios and then generates these large tables directly from Databricks, believing that this is the holy grail, and then asks you to please consume it exactly like that in BI. So that actually exists as well. It's rarely found in the middle ground, but you find it both among those truly at the very other end of Excel, but also from the hardcore tech world who also don't quite understand or even want to understand the star schema.
For me, it's also the case that I'm absolutely no fan of wanting to break down a large wide table in Power BI. I'd rather have it pre-modeled accordingly within the system, and if I see the opportunity, I naturally also try to retrieve the appropriate breakdown directly from the data sources. So I simply don't want to have to process this wide table, but I want it already separated based on the data, because various problems can come with it. One topic that I believe is somewhat debated and which many people discuss is the issue of performance or memory usage. Even there, I noticed that, of course, everyone talks and says, "Hey, star is better than flat table." I just had an example here where I had taken larger amounts of data, but where there was also a corresponding and quite significant size difference. I didn't notice performance-wise that it was so incredibly bad to have one big table, but size-wise, and you could see it. But then again, the question is how you divide these tables and dimensions. When I've taken smaller amounts of data and then the core data that I've utilized within that specific framework, most of the time you'll find yourself running into this particular predicament. You want to accurately recreate the scenario, and so you simply pull the entire star schema directly into a flat table.
What happened here was that the customers who weren't selling were then eliminated.
Great.
Even with the Christmas background. Hi, Andreas.
I'll keep going anyway. I still need to get to my point. So in this case, you suddenly noticed when the data rows were smaller, and I had these scenarios where the data was structured in such a way that I perhaps had more people or more customers in my customer table than those who had actually made a purchase. So if I have a large number of interested parties or prospects without any actual sales movement, and I were to include them in my analytical model, then I currently cannot analyze them using the one big table, not in any way, shape or form, because I truly only have the one big table for sales data, and it only contains customers who have completed a corresponding transaction with me. Bekommt in a die Baskan, der kommt ein näher. Within star modeling, they could certainly be part of the dimension, but they could also consume just as much more memory there and thus make the star schema larger. So you also have to think a bit about that when you're implementing such modeling approaches. You cannot simply say that one consumes more memory than the other. It truly depends very much on the modeling. And I have one more example to share, because we've often talked about it in that context, that you pull in an additional dimension of facts and one big table. That's actually thematically quite relevant here. One has to admit that Power BI brings various capabilities that somehow make the one big table concept possible. So for this particular section, I've gone ahead and implemented a line chart right here at the bottom. And because I've truly formatted the date column as an actual date, it automatically utilized this specific series axis. This implies that even if some date values were to be missing, it wouldn't really have a significant impact or cause any major issues here. He simply builds this continuous axis based on a date. So he already has date intelligence built into the chart in the background and can display the corresponding values.
You're showing a continuous axis, not date values.
Yes, exactly.
I wanted to assess that with numbers too.
Yes, that's exactly why. But he still recognizes that it is a date value and that he treats this is continuous axis here as continuous. It can be displayed, and consequently, any missing data values would simply be skipped over in the graphical representation, which is also possible.
What I was getting at, it has to do with dimensional or non-dimensional. If you were to switch to categories, you would see there's a difference between the dimensional and the table model.
Yes, but as I mentioned, that the main point is also that Power BI is quite forgiving, so it allows for this within that framework, because if you truly work with the date values, you could still get a result using this big table without you would really have to start building a date table where every date value is present to have a continuously categorized bar. And sometimes people are always divided on whether they want to see the unposted values or not. It's similar with customer groups. When you suddenly ask, where is the customer group? It's in the system. Why isn't it showing up in my BI model? Well, because we currently haven't assigned any customers to that group. Or there are also these kinds of issues which one could definitely resolve if one truly wanted to, for instance, buy a modeling of a snowflake schema, meaning that you actually add a table to it where it's ensured that all customer categories are included and that it then connects to the corresponding customer table. What I had here, that the other simple solution would be,
if you're preparing the one big table from your dimensional data warehouse, you don't just do an inner join and then an outer join, and then you also have the joins.
Yes, that's exactly the topic I've been thinking about as well. The real question is how much this whole thing will actually build up within that specific framework. And I've actually just done it again, specifically for this particular case. I somehow had an AdventureWorks topic and didn't want to pre-generate the entire one big table myself somewhere, but instead put it together within the Power Query schema. Which, by the way, is also perfectly possible. We'll quickly type this up now. So some hypothetical data that one might have. Now, for that, I don't need to create a new dimension or a new fact table, because you can handle that here just as well with the one big table, just as you might do it perhaps in a star schema. If you say, okay, I want a star schema that has a large fact table, you simply say the values that I cannot assign, I'll leave them as an unknown member. Run, or in this case, as far as I'm concerned, run to 0. This means I could simply append my planned data to the sales table right here, which is exactly what I have done at this moment. I don't have a field now to separate the planned data from the actual data. Instead, I have a separate column where the value is. That means if I sum up the quantity, then I get my quantity, which comes from the actual data. In this case, the plan data is then simply assigned here to plan. Quantity is completely empty for the IS data. For the lines below, it's the exact opposite. And these plan data can currently only be analyzed based on the store's country code. I didn't actually include the store itself or the customer in this part, but that doesn't really make a difference because essentially once it had completely loaded all the data, I intended to place that right at the top. At this moment, I currently had 2 stores that were specifically from the country section. It's been imported. Just leave it for a moment. Okay, the data is on GitHub and the base data gigs, and it now has to reload all the cell data again because I just added it. But it shouldn't take too long as it's not actually that large. Exactly. Then I also have a column right here with the plan quantity data, and I could have them aggregated into the total here. And then I can clearly see that the corresponding planned values are included for these specific store country codes. I could also include them here in the line chart. You would then see a straight line and also notice that the data points only appear at certain specific locations. And now with this display format, the issue would be that you'd probably prefer a cumulative view because the values here are already cumulative at the monthly level within the planning data, while the actuals are still recorded on individual days. But you could also, for instance, incorporate this through visual computation with the respective, what is that, rolling sum, continuous sum, what do you call it here, a running sum, a corresponding running sum. So it's quite graphical within that framework. So I truly believe that you can solve certain problems within the big flat table and that you can make use of them. I don't want to demonize this at all. However, I am convinced that specific modeling techniques are required for the flat table and also for the corresponding DAX statements. If you pursue this approach, which is different from the star schema, and I truly believe that the star schema, especially when it comes to the topic of reusability, holds a much greater value rather than making any real difference in terms of performance. As I said, I just showed it regarding size. You also need to check the data's state to see if a star schema truly compresses better than a flat table. And you will very often encounter this scenario where if you take a really close look at it, you would then proceed to say, okay, I can, but I'll simply leave out the following columns in this specific scenario. Then the entire thing becomes much more compressed again. That was the main point, to demonstrate, yes, okay, that's essentially where I started with this.
And that's the transition to Martin's question. And Andrea will probably have to wait until the end because Martin has something that, in his opinion, has advantages. I'm quite curious because I picked up on it from Marcus, and then I thought, well, Technica advantages, okay. In case of doubt, Anton might not be all that interested, so I tried to really highlight the actual user visible benefits from my perspective. Well, for starters, once you've got more than a single fact, things get complicated. It's still okay if you just sum and have 2 values with similar granularity, okay? But as soon as not all dimensions apply to all facts or granularities differ, so typically I plan on article groups monthly, but I have the actual values on articles and daily. And then there's that. You could also try to do that in a big fat table, but the DAX formulas you then write are simply more complex in all likelihood than just remodeling it in Power Query into a star schema. So that's at least my opinion on the subject, which is one, I always have very little patience or understanding when people come along with their data bricks and then say, hey, you're introducing unnecessary complexity with your star schema. And that's exactly the point Greg then picks up on. So complexity follows complexity. You build a model and then you have to create complex DAX formulas just to interact with that model. He's absolutely right. If his reference truly is an Excel with identical granularities and a single fact, then I would agree with him. For everything else, I mean, come on, then just a simple star, even if it's somehow the same thing that we'll see from me or from Martin in a moment, that also goes in that direction because it's just so easy. But yeah, Marcus.
Well, yes, exactly. The question, of course, is what kind of calculations do you always factor in? So how many people go much, much further beyond the sum methodology? And what we've already seen here, we've used different granularities, and I could, in this context, simply write the value to the store country code and didn't have to create a planning store or such to put the whole thing into a star schema on a country's country code to be able to store what was otherwise in the dimension. So I only needed to fill this one column by which I want to enable the analysis, and I left the corresponding store information blank. That means it's running smoothly. So I don't necessarily have to fully populate this dimensionality in its entirety, especially not at the most granular level. But I was actually able to simply apply it to just this single piece of information. And if I were to look at it here in the...
Yeah. Okay, so you essentially have an empty pseudo store along with it.
Exactly. That then results from the fact that you have this empty here, and that is then...
Here is the corresponding
unknown member.
And now we have the same thing again with the dates and with another dimension, and eventually you're trapped in an unmaintainable hell. You just can't, with one dimension, you have this way out. I believe it just gets exponentially more complex when more are added.
The question really is, what do people expect? So this is also the main point. If you were to go there today and didn't connect a particular dimension, then it would divide the value or repeat it X times for all the things that it cannot properly assign.
Yeah, so there were comments under my post where I had called on people. For example, Philip Stemfel also said, well, you could, for instance, use quantity and plan quantity as a column, so like a column metric, and then you would still only have one column for the total. I would actually find that even more elegant, but then again, it's not really how people are accustomed to it from Excel, and then you might as well just put a star there again. So in that case, it's already BI specific anyway. Exactly. Andrea just brought up the same point again. She's providing support from off screen. In that context, how would you actually show the monthly figures if the planned values are at the start of the month and the remaining level? Well, probably by accumulating them, I suppose, but... Okay, you even have this here. Okay, then you have your role here.
I need to turn my mic back on. Exactly. I had for one, I had written the first one here in the order date. You can see that the value is only there then. But if I look at my orders here in this table right now, oh no, I should have also displayed the order date field, specifically broken down by months. That would have given me the sum I needed. Currently, it's just accumulating everything. Should I have included that other column or perhaps structured a new column specifically for this purpose?
This is now essentially the return journey.
Well, factually, it is. You don't have to look at it daily, and then you'll see it monthly. And if you filter for just one day, well, then you'd have a problem either way. That's, again, such an expectation. I would then say, okay, the plan would also be linked to the first date in the star schema, very likely. That means you wouldn't be able to filter on the second one either. The plan would be lost, just like with the big table. Only if you then, I'd find that. I always find that as soon as there are multiple dimensions, it just becomes so unnecessary for me that I'd simply say a star is easier. but we'll let you do that. And then I'd like to take on Martin's challenge. Since I'm already speaking a little on the audio track, because another example I mentioned where a star schema is definitely better, then I just have this topic of and or filter. But first, it's your turn. Okay, you have the months here. Okay, good. Yeah, that works. So I don't necessarily find that if you only look at it with just one dimension, it's not that bad at first unless it's not continuous. If you don't have any values for a month or something, it looks strange.
Yes, but that's what you often see nowadays. Well, when people are working in Excel or something, they have a date column and then they add a new column, similar to what I've just done here as a calculated column, in which they reformat it themselves, and they do that 3 or 4 times. And what you could do now, if you also had a delivery date included, then the question would again be, okay, how often do I have to import and reformat my columns? In a date dimension, I might have already predefined many different things, but perhaps in my flat table, I would also include a varying number of columns asked for the date, because I might consider an order date more granularly or examine it with many more facets than the delivery date and so on. That doesn't necessarily mean that just because you might have a date dimension, you would suddenly set up the one big table with all date characteristics and column possibilities here in this one big table as you might typically do.
I already see the first ones noticing that's what happens when you have viewers. The months are sorted alphabetically, yes, and then you naturally have to make a column for the number.
No. Just a moment, please, right there.
You have to be careful. You can also reformat the order date or convert it in such a way that you can... That I use the date function here, for example. Let's see if I can still quickly...
So I'll just input the relevant values right here. This isn't really a one big table versus star schema problem. You would have that issue regardless, wouldn't you? One could simply state that in a star schema, it's only resolved once and then the calendar is simply present. Now it's also slowly becoming quite extensive, if I may be so bold as to say, Marcus, I truly love your one big table. You know that? I'm not really the one who, yes, he was pushed into this role because the others, I believe, are much more radical. No one would have volunteered for the one big table, would they?
I don't know, but I don't want to push that away too much. What I've done now is I've created a specific month column where the month itself still remains as a date, but where all of them are summarized to the first day of that month, and then I just use the formatting. And the advantage is that in the background, the numerical value of the date is still used for sorting. That immensely saves you from having to add an order by column, which you would then also have to use for certain DAX constructs, the filter from both columns, and so on. So that's definitely something that I've become very comfortable with now, to say, okay, I'll create a date column that I make at a different aggregation level and then work with formatting. Although a beginner would have to say that just reformatting the date and then you have 30 different values in the month that are displayed the same way, that doesn't make anything agile at all.
Oh, that's right.
If I were to choose the correct approach, that's precisely where the danger lies. Anyone who believes they could simply take the order date field, drag it over here, and then declare, oh, for this order date, I'll just display the month and the year, then they might indeed select that display format, but it still inherently contains January 1st, January 2nd, January 3rd.
January, etc. That was pretty bad. He was there 30 or 31 times.
Yeah, that's a bit shitty, but not half as valuable. Exactly.
Yes, and I then searched for other examples. Okay, if it's not just about granularity, I eventually landed on the topic of and or filters. Like, you can filter well in Excel, like an or filter. You have 2 items, you filter for them with an and filter. Which customer bought both? You already have to struggle a bit in Excel, at least I do. And that's why for me, the one big table is already quite unsuitable. But Martin picked that up and then somehow made a challenge out of it. So I'm bringing him up on screen now. He's been waiting this whole time because that's the assignment, and I've already approached it that way. But tell me, why did this topic concern you so much?
Well, I read your post and then I thought to myself, unfiltered and simple and Power BI, that must somehow be a different tool than I know. Unfiltered and simple. That's not how I know it from Power BI. And then I said, well, show me that it's actually easy. And I would say, I'll now demonstrate the requirements, the mechanics, and then you'll show how simple it is. Yes, I believe you've definitely implemented this differently, but I'll show it first, and then you can critique it a bit. Show us how you've done it.
It would be good if you solved it easier than I did. I know, because you said it's easy. I believe easy is relative.
And the requirement is, I have customers here, and I have here, just to compare the behavior, the OR filter, which is the standard behavior. So that's what I would also describe as simple. And then here the A and D behavior. I want to know now customers who bought cheese. And since I don't have anything to finalize or process yet, I have the same list twice here. Has anything even happened? I'm asking myself right now. No, it's still calculating. My computer is now using the query. Yeah, it's still calculating. And now I just need to quickly raise the priority. So what you would see, you'd notice he's lying. He's not lying.
Hey, now?
It became clear. That's why when you make use of an object, it is always slow. So at this point, the outcome is identical on both sides because I have only applied a single filter. Now I want to know which customers purchased both sausage and cheese.
I see now he's still laying. He's being very diligent over there, working hard. And
now I see that the customer list in the OR filter is getting longer logically, because now, in addition to the customers who bought cheese, all customers who also bought sausage are added. And with the AND filter, there will be fewer customers because those who only bought cheese but no sausage will be filtered out. That's the requirement.
Yeah. Okay. So that's you. You're the one saying that. I thought it was with a kind of. No, actually, it's you who's dealing with this. No, exactly. Let me show you how I build this, or what I was thinking when I did it. And this is basically the finished product. Then we can dive into the measures. So the idea is the same. I've broken it down a bit here for transparency. This is the star schema here. So the variant where I've externalized customer, article, and calendar data, and the main table itself only contains their respective ID numbers. Exactly. And then I actually did that with both of them. So clearly the revenue here is trivial. That's simply just, revenue by having price times quantity in SAMX here, because it has to work per line. That's why. But actually, it's just syntax sugar for certain sums, but clearly, so that measure is somehow dead and people don't freak out. Does that make sense? So here it's just trivial. And then on the side, I also have this article counting. This is the OR behavior, isn't it? Exactly, that's the OR behavior. So essentially what's set by default, you can clearly observe it here. If I delete this entry here, I'll still have these 133. And if I start adding cheese here and then sausage, it will then sum them all up. So what we see here, sausage is 15, cheese was 17, 33 in total. So that's pretty standard. And then I have the word and. And for me, it's like this. I like nesting. I don't like virtual tables or long measures. So this is certainly a solution others might not have chosen. Well, and you probably did it differently too, Martin. This number of articles which I've included here again is really important to me. And that's naturally crucial for me. And where I filter articles, you see, I simply have the filters there. Ultimately, I count the number of articles I filtered. If I filter articles here now, there are 2 of them. If I take one out, I've only filtered one, and that feels like a gatekeeper here. We should only count the revenue from customers who, based on my filtering, have actually made a purchase. If there are 3, only the total sum is then included. The others are set to 0. This is also clearly visible and traceable in the table. And since this revenue is all selected, it's actually just the same thing was you could also build an if statement. I learned that from you, Martin, but with the divide function, it's even better. And then I also implemented that for the small use case that I essentially take the number of items the customer just bought, divide by the number of filtered items, and round down. And obviously, if it's practically below 1, it's 0, and then my entire revenue is also reset to 0. For me, an advantage, for many others, a disadvantage is that it also shows up here. Customer A bought nothing, but he still somehow appears because he's also a customer and is simply visible. But for me, that's precisely the major benefit, because this measure filter article operates solely on the filter table, and no matter what else I do with my fact table, I mean, I can activate other filters. There are no interferences, which I always hate with one big table. If I add more filters, then it breaks some logic, then it gets more and more complex, then you use all except with very long chains, and actually you just need to fix your model.
Where did you count the articles now? So in your lower table, the middle column, on the fact table, or on the dimension, the articles I have here, so to speak, the articles per customer is also a fact. That's why, okay, it will be the fact table.
What would you do in that case if you were to take the article groups instead of the individual articles? Because then you can no longer differentiate between I'm counting on the fact table and I'm counting on the dimension. Yeah, then I would then.
Good point. That's true. Yeah, I can just, but that's not a pattern you currently have that you can simply use universally. Yeah, good, yeah. So if I'm looking for other things, obviously, because just the fact that I'm specifically filtering here, that alone makes it not a pattern. I found it interesting only in that particular respect. It was actually, with my current method, more difficult to solve using a single large table, because that's precisely where I encountered this specific problem. These filters are also dynamic and I can't really get rid of them. Oh, that's really annoying, and that's why with the OBT I then have an extra intermediate layer, because I have this filter OBT first, and then practically everything where I just throw out again what I absolutely don't like at all, to discard any hidden filters, just because my model isn't a perfect example. And sure, one could now solve it with no calculate using virtual tables. I am also aware of that, but I wouldn't find that any better either. And I would still be of the opinion that no calculate is not readily understandable for the users. Someone would even gladly argue with Greg if it has to be. Yeah, exactly. And in itself, the one big table works exactly the same way, except that I additionally have to throw out this context, and I have to, well, work with values here, because virtually everything's included, like customer name. It makes it harder for me to iterate, so it's a little more complicated. That's absolutely right. And now, Martin, you're saying quite justifiably. All right, I was counting something on the fact table within the star schema, where I was essentially looking at the individual items. But what if this specific item number doesn't actually provide that information, and instead I'd have to count the groups myself? And you were kind enough to also provide me with the necessary table for that. I just need to import that data now. So I'll just quickly and dirtily pull this into the mix here by me doing this right here. And I've already dealt with that particular issue. At least I did manage to get it downloaded. And then... Can I have it here? All right then. And now I just need to check if the table still has the exact same name. Yes, exactly. Here we have an item group, and that will probably make the whole topic even more challenging. I'm going to make this the text now, and I would say that the rest hasn't changed here. That this article is only for Stern anyway, so I'll just delete all of that and I'll just slip that in there. Then the rest should continue to work, unless the front end and back end start acting up a bit again. So I've just snuck this column in, and we'll see in a moment. Yeah, but I didn't pay attention to the OBT naturally. Let's take a look. So, yeah, I should really check, is the relationship still there? Yes, that's okay. A table was painlessly exchanged in the back end. That's why this layered architecture is worth it, even for small models in Power Query. But what Martin actually wanted is, and I'll just copy this, my beautiful star schema, which will then immediately break star groups, and specifically not the articles, but it's about article groups. Then I'll just have 2 left. And now it's doing some pretty wild things. I'll just create a small glossary here, basically showing what belongs to what. And I'll remove the filtering for a moment so we can follow along. Exactly, we actually only have 2. So at least for now, there's no N-to-M group assignment of any kind. That would have made this situation even more difficult. But for articles, there was only 1 group. And if I were to go vegetarian now, then under cheese and bread, the entire amount would correctly be summed up. We see very clearly with the OR operator that this works, and with the AND operator, it would only be those who bought cheese and bread, so customer G would be the only one. And funnily enough, it works. I'm actually quite surprised myself. Yeah, okay, I get it. Yes, of course, because as a select, I now...
Who bought all vegetarian items, but rather who bought at least 1 vegetarian, and if selected, at least 1 whole food item.
So it's not like a selection of multiple items, but 1 from each group. Okay, wait a moment. Then I've completely misunderstood that from the very beginning. Wasn't the other one already like that?
If you take it from the shelf, it's because that's also no matter if it's bread or cheese or both. Okay. But Arthur, you'd probably just have to go into your own first count, then check your filter again. You would need to count how many article groups you possess, and further down you'd probably still need to bring the group into your distinct count using related for that distinct count. So not count number of articles, but rather a part that has number of article groups.
Okay, so first I'll just check again. What is the expectation? In any case, it's definitely wrong here that it has a 1 for full value here is now, but well, no. But that's also, well, yes and no, because that's also the overall dimension, but I do understand why, because he has, I mean, I've practically, behind vegetarian, there are actually 2 distinct categories, and the reason why there's something listed under whole grain here, that would then have to be selected value. Okay, but I would still, one more time. Marcus, I wouldn't even make a case for that. You'll probably have to tell me the solution again in just a moment, but I was still a little bit taken aback by the requirement, because then this whole thing would have been misunderstood already.
No, it's still correct in here.
Because I did and said this and that and that.
But for the group, it is enough if only 1 item from it is purchased to be included.
No, not bought from the group, but rather who has Okay, who has an article? So that's perfectly fine then. Basically, anyone who is somehow involved with this group, because everyone whom this group affects should then be filtered.
Exactly. Everywhere where you have a 1.
When thinking about this question, you can completely disregard the articles. Whether they exist or not, it plays absolutely no role in the question. Essentially, all I need to know is, does this group appear or does this group not appear?
Exactly. You could just go to the fact table for now, where you have your distinct count. Yes, you should actually be able to go there.
Yes.
And you would have to do a distinct count on the item group here.
No, I can't. It's in that dimension. Of course, I had a clean star schema, so I don't need any.
Yes, but isn't that the topic with the expanded tables, where you can then say that you can use the relate function?
So if you start with related now, it would probably be possible. To be honest, I've never actually used that because I believe I would actually, but perhaps relator is also more efficient. I would rather look at it this way. Is the line, so to speak, a deliberately chosen one, or is it a selected article or not?
That means, but otherwise you won't know how to group them. You must combine them into an item group.
Yes, well, okay, but the group, it already filters out the individual fact lines. I simply need to know, is there anything relevant or not for each specific group? That means I would probably go for, but that's really just a question of style, isn't it? I'm not even sure if with this sum x values approach, I probably often do things that no one else does, but I also don't use relate in the same way then, because if I were to say I iterate for each group, and then he should just check if the number of articles is greater than 0, then it's just 1. So I might be mistaken here. I've overlooked something, but essentially the number of articles should simply be divided by itself. Because as soon as that value is greater than 0, I will simply output a 1. With this particular type of division, I would then essentially have for every single line within the context, regardless of how I decide to filter it, I'm not sure if it's the most efficient way. I even suspect it's not, because I'm practically going through the entire dimension per line and then also grouping them with values, and whether it will even work hasn't been confirmed yet. But if I look here now, I see that it's a 1 when it appears. That's actually what I want to achieve, because if I add the other group, I'd expect a 1 everywhere. If I deselect it, then for people who have something to do with whole grain.
It can't be perfect everywhere.
Yes, but if I select all?
No, it's supposed to be the and then grab it, right?
Hold on. Why are there? Yes, absolutely. Can you just click back? Customer C has already taken care of everything.
Yes, that's correct. He did both. Who was responsible for all of it?
Customer C didn't do everything, if I'm right, no?
Exactly. It only has 1.
He's got nothing but nonsense. He's practically vegetarian by Martin's logic.
Yes, exactly, that's right. But he actually, in that sense, he has product group 1. So for him, there's only 1 group in the shopping cart, whereas for him, 2 groups appear in the shopping cart.
But you've got and there, right? So it should apply to those who did both, and customer C only did.
Yes, exactly. That one definitely needs to be removed. Yeah. So this isn't quite finished yet. It's just an intermediate step. Similarly, with this filter here, I shouldn't be looking at articles anymore, but rather how many groups I actually have. But I'm not entirely sure if that's going to work out, because it might then end up being assigned to the incorrect groups. It's possible that it functions correctly with 2 groups, but not with more, because I can, of course, implement a distinct count on the item group. Well, that's how it's operating in that dimension now. That in itself is a rather absurd situation, that there are always 2, but then in case of doubt, you might also find just 1.
This is already working well. That's good.
Yes, and then I could, in a sense, modify this revenue figure from selected in such a way that I would essentially be applying the group logic I'm doing. So that's not necessarily simple either, but I suspect I'd have an even harder time with one big table, which of course one might perhaps dismiss as a matter of taste, or rather I'd like to see how that could be simpler if there were actual advantages to one big table. Because that's actually what happened now. They bought something with this group. That's where it shows up. And if I look over here, they have vegetarian options. So these are all of them, although exactly. Yeah, right, because they only have one. They're supposed to be gone. But if I only focus on whole foods, then that's probably wrong because some items here are below the whole food standard. Just miscellaneous and sausage. Is there anyone who only bought cheese?
Yes, that was C.
Nevertheless, it's in. No, it's not in.
It's working now.
That's definitely safe then. Okay, then maybe they were vegetarian as well, so that's less. A, for example, isn't included. B isn't either, but the others are. So that works out. It's not really, yeah, what do I essentially have there? What have I done for it? Pause. It's just with these sum x values, I've also used my favorite pattern again. And naturally for me, this particular dimension provides a significant added value because I would have otherwise never been able to accomplish it, or only with a much greater amount of effort to implement that using a big table to essentially go through this specific logic. I'd have to remove at least some filters, and as soon as I just slap an all there, but then still want to filter further down, it wouldn't work here anymore. What I find charming about the star schema is that you can build it in such a way that it just works. No? I could also have 100 other filters they apply, regardless of what I'm doing there and how it might not be perfect, or I really don't know if that's the case or if he's now such a huge, almost massive logic with virtual tables, if that would really be better.
All right, I just wanted to quickly mention I really have to leave now. I'll definitely catch up on this later.
If you have constructed more than 10.
No, I didn't build anything with Relate, but you still want the other one. See you then. Bye. We need to continue this again, Yuto, because thank you for that.
Exactly. We'll probably do it again, but not so much under the Data Days banner because I actually have a tight follow-up appointment. But first, thank you, Marcos, for the introduction, and thank you, Andreas, for being here and for the input from that side. And we can see, Martin, you can quickly respond now why you believe one big table would be much simpler for him.
I feel somewhat validated that it's not easy. So as I said, it's a question of how you define easy. But we've seen what you did that for me would certainly not fall under the definition of easy.
The concrete answer I would give right now is one big table.
Not any easier to solve, but it's also not much more difficult to solve.
Most likely, yes. Well, the original subject matter was actually quite similar. And what I personally appreciate about these is that each individual measure can somehow stand completely on its own, and you can easily explain what its function is without having any wild, all-encompassing, accept all elements included.
But I mean, the major drawback of the dimensional model you've already observed in your attempt or your proposed approach, saying, no, it's so complicated that I'd use related. I don't even want to go that far. If you'd like, you can record my screen once more. Yes, I can do that again, right at the very end. I would then say, okay, some measures are really simple, some measures are really simple, but the bottom line is you can't say that you're better off with the dimensional model. On the contrary, I would say the users Those who currently possess limited experience with DAX will more frequently achieve what they anticipate and what is essential for them using the one big table model out of the box. I've got an example here for you that the file simply contains two different versions. Here, dimensionally, I've just gone ahead and counted the product groups without using any specific measure. So the question here would be from how many product groups did the customer buy? And because this is a dimensional model and because the filter relationship is unidirectional, all existing product groups are always displayed. Always two. If I do the same in the one big table model, even without a measure, I always get the correct value automatically. With the one big table model here, I can always view the raw data. I don't need to drill through pages or such. I can always trace how the data was created. I can do that in the one big table model too. But what do I do in practice then? I then rebuild the large table as a visual. And that's the next problem I always face with clients. They go into the data view and then they have a one big table model. You suggest to them you want to build a dimensional model. Then they say, yeah, sounds good. I get it.
And then you build it. And then they look in there. And then they say,
they want to validate some metrics, and they look at it and say, oh, now I only have my surrogate keys in the fact table. How am I supposed to understand how my numbers are generated? What do you do then again? Yeah, you build them another data model. So actually, so not a data model, but a visual that again reconstructs the one big table. What for? You're handed the correct values here for free. You're handed the drill through detail view for free. You can easily validate the data, and then you can start writing your measures. Now we can take a look at it. I could, because you say, okay, I want explicit measures. I want to count the product groups that are being used here. Then I'm actually back here again. Just easily on the go. I'm taking my measurement and article groups, the distinct count from my article group, from my one big table model. Yes, so. Well, aside from the fact that I don't really need it, if I just want to do the same thing right here, right? So here in my dimensional model, I'll certainly need it. We just have to wait a moment. Well, okay, sure.
You'd really have to fall back on the dimension itself, as it were, but
just do it quickly. No, you can certainly guide me through it, just how you would do it. So now we're making these article groups dimensional here. So O is calculating again now. No, it's still not quite ready. But you could already describe for us how you would go about doing it. What else do we still need? Probably, apart from the distinct. Yes, I mean, we'll almost certainly still require the distinct count. No, but we would now count based on the article dimension because nowhere else do we actually have the article description. What else do we require? If we did it that way, it would always just result in 2. But that's really not what we're aiming for. Well, then I would apply the same approach I used before with some X values across the article groups.
And so if I do it in the dimensional model,
I would simply reconstruct the one back table by expanding the table once again. And then then it just takes all the rows that are associated within the fact table, right? And then I would have exactly what I need, but now just try to have someone do that who has very little experience with DAX, you know? You do that completely differently again, unlike me, for example. So it's not that straightforward either. If we take this now, Let's see if he's already ready. I still need to confirm it. And for me, with many years of DAX experience, this is naturally quite simple. But for me, it's also easier to build that in the OBT model. That's perhaps not the standard. But in the OBT model, I think beginners more often, more easily get what they
All right, you're keeping track. Okay, I'm just wondering if we happen to have any more filters. That's still very straightforward. Exactly, you've got that now too. We probably also still have a blend group. Okay, but here they are. We have, yes, but
3 and 4.
We first need to check what is in the data. Well, when you think about it, there are really only 2 groups. I'm actually quite surprised by that myself.
Oh, we're perhaps not counting them as distinct. Mm-hmm. Oh no, we're actually counting the articles right now. Yes, yes. Isn't that precisely the mistake we're making? Yeah, no, you're absolutely right.
Yes, exactly. Then I will count the items. No one saw it, no one noticed. Very good. So now the same result should come out. Okay, yeah, exactly. So I wouldn't recommend the one big table model for conceptual reasons, but rather primarily for tool-related reasons, because Power BI simply gives you so much out of the box when you build it on a one big table model, and so much of the default behavior that you then get, that's what you generally need.
which, in my opinion, is more obvious for the beginner. Yeah, well, all right. Marcus and Andreas had already wanted to revisit that. I'll have to give it some more thought. So we've seen for this example, that was for both examples, okay, I would have to go through that again with the group for the one back table to then find out, okay, the other one was minimally more complex for articles, whether that is now simpler again, because it somehow seems to be the case. You know, you're absolutely right about that. One can now, without needing any specific calculate or sum X system, simply count it much more effectively per customer. And I'll have to take a closer look at where I might encounter some limitations again, and I would then have to go over that one more time, you know.
Well, even if you set boundaries, the question for me would be, are these boundaries that a beginner, a self-service user, like a less experienced DX programmer can overcome on their own? If they can't, then the solution is already worthless compared to the OBT model. Well, whether that's so easy in the OBT model, that's the question.
Perhaps it's not any simpler in either of the models, and then it's simply not suitable for the user, for whom I'd recommend the OBT model.
The question still is about this AND filter. Well, how would you ultimately solve that in the OBT model? You'd also have to somehow write that down. At least
we can just quickly check how I solved it in the dimensional model, so you can see how little difference there is. So I can take this out again. I just wanted to quickly check how the article group filter works. I've tested it. It definitely works. So for me, both diagrams look exactly the same. I always have the customer name and the revenue as a measure in both filters. We can also take a look at that. I hope that it filters a little faster now. Exactly. And so there's a calculation group applied here now. In my terminology, this would be what I call a context modifying calculation group, because it's specifically designed to select the customers. And We can look into the calculation group itself.
This one also looks super simple. I simply input my UDF end filters right here. Here I can specify any pairing of columns that originate from two distinct dimensions. So customer here would be what I intend to filter, and item would be what I wish to connect, and selected measure would be what I plan to calculate within this specific context.
And for that purpose, I have the UDF. I can quickly walk you through it. For those of you who might not yet be familiar with ODF, the header then simply passes on all the necessary parameters. And first, I check maxime. I check if it's filtered at all. Yeah, pause, because otherwise, if nothing is selected in the filter, I'd see nothing in the end view. Pause as the statement, or very little as the statement would then be all items must be purchased. Pause. To prevent this, I'd only do it if no filter is set.
Well, this is the situation now. Then I'll just use the dimension table.
Mm-hmm. Well, that's definitely already quite a lot. It's a...
Yes, yes, it is universally callable, so UDF, and I don't have to assemble and filter multiple measures. I can do it on any pairing of columns. So this is a pattern, which is why I'm doing it like this. And here I'm counting the selected articles. And then here for each customer, I count how often the measure, which in this case is the revenue, is not empty. So to count if there is revenue for all articles in this example. And then I simply remove those for whom there aren't enough articles generating revenue. And then I calculate the measure within the context of the identified customers. And now the only real distinction, or the only difference to that, when we look at the one big table model, now I believe I then shifted it into measure here, but I'm not entirely sure if I actually reconstructed the UBT. This should be the correct one. So the really crucial difference here is now that because you have everything stored in one large table, you explicitly have to remove the filter that's set for the customer in order to get the total count of all the articles. That's precisely what you had mentioned. Because I am in the facts table, when I am in a customer context and then count the items, I only see the items that the customer has ever bought. So I have to take that off just once. So first I need to determine the article's specific context so that when I'm counting the articles, I can remove all other filters and then count them. But that is the essential difference. And then when you can do with the same thing with the function, and it is just as universal, the algorithm is exactly the same. Yeah, a function is really a cool thing.
Well, I can clearly say right now, if you make that available as well, then that would certainly be something that could be utilized as an unfilter. What you have definitely given me to think about and consider is that the topic of, well, default behavior and so on means I need to find a scenario where the UDF isn't just minimally more difficult for me personally in DAX and somewhat unintuitive, but where it is actually more challenging for certain specific expectations. I didn't have that out of the box either, and in the end it was similarly complex, so I had saved myself an unnecessary intermediate step, just as you mentioned, by removing additional filters in the OBT. Then I said, if the model handles that, I don't need to do it in DAX. Where that then exactly is the sustagen pause, as it were, and pause. That's not the one huge advantage that now completely overshadows everything else, but I'll just have a look at what else I've got. Especially we see there are situations where I explicitly have to remove the filter to get the result I want.
But then conversely, there's the situation again where in the dimensional model, I explicitly need to apply the filter to get what I want. So sometimes it's one way, sometimes the other. Yeah, but from my perspective, you're still closer to the real world if you explicitly filter instead of just removing it.
But we're now again very subjective in our expectations in this area. In that sense, hello, Michael. We are now already significantly over time.
I wanted to add about one big table.
Okay, now make a final announcement.
You always did such a good job highlighting what the technical advantages or disadvantages are. No, I think I've actually focused quite a lot on the users. Yes, I wasn't present for about half an hour. My apologies.
My experience has always been that beginners sometimes with a small, so a one big table usually isn't that big. It then somehow has between, let's say, 10,000 and 100,000 lines. And especially in such a simple model, it can sometimes be that they thereby get a quicker understanding of how such a BI tool works. And then little by little, such a one big table also moves in the direction of, oh, now I've added a date dimension. Perhaps eventually I'll have a product dimension. So little by little, there is an evolution, how it then more and more shapes itself into something dimensional. But especially for beginners, I sometimes find a one big table quite good so that they can already understand this concept of row-based context. Because if you start with someone who comes from Excel, you often get the other one big table that Power BI can't work with, namely the cross tabulation. And then this evolution to the one big table where everything is in one row is already the first step to then gradually guide them towards a fact table, and then to say you wouldn't want to have 20, 30 rows standing next to it containing various date attributes, but we can now clean that up and move it into a new dimension. And the emphasis in the next step is, well, the same for products, the same for countries, and gradually an evolution unfolds. But initially, if the use case is simple, one-dimensional in its metrics, you can also say, then just put it in a table. No need for much effort. Dit skivan en deze man hat es so.
Well, I also see it that way, that there are certainly application areas in the traditional model. So at the very latest, if you want to perform a drill across, which means you're dealing with several fact tables, then you will certainly require the dimensions. Or if you possess standardized dimensions within an enterprise context, something like one, I see the advantage then that users know and recognize the item master and can navigate it faster if it's the same in all models. So there's always the question, who's going to build this thing? And then again, it's primarily a question of what skills does that person possess and what effort are they willing to invest? And I've already shown that validating it is easier, getting the detailed view is easier, and aggregating data is easier. You simply get what you need faster, usually with a one big table approach, especially as a beginner.
And everything else, everything more complicated, you won't get quickly as a beginner anyway.
Yes.
I'll think of something and then we'll eventually, at some point in a deep dive or a follow-up session, we'll pick that up. Before we hear...
I think what you also notice is that there are many intermediate forms between one big table and perfectly modeled star schemas. A prime example is something like junk dimensions. Yes, no flex. You should actually model them out, put them into their own dimension, but in reality, that's often just not done because the benefit is simply not proportional.
So if I were the department now and my IT would give me a star schema, then I would simply turn on the built-in date table and say, now I have a star schema.
Yes, this minimum OPT plus calendar actually does exist in certain circles. And so for those of you who are still waiting, because we've gone significantly over time here, and you're only here for the code, you should definitely get it. Here, your free certification. Yeah, free certifications. Just scan this and we will upload the translated version some days after this. So check out this channel and hit the subscribe button. This is very important. And a big thank you to everyone else who joined in. And a special thanks to Microsoft for their support. We actually had quite a few more people here than usual, at least judging by the numbers. Otherwise, of course, Andrea, who contributed a great deal from behind the scenes, and Andreas, who was present and also Viviana with some valuable suggestions. Thank you to you too. In case you're still watching, we have certainly run over time. All right. And of course, thank you, Martin, for the use case, for this inspiration. I will certainly incorporate that into a post sometime. I also found this topic with Michael, this theory of evolution, not bad at all, to say, well, the one big table concept is already a significant step forward compared to what currently prevails in the various departments. And that's actually quite interesting. Yes, in that sense, we'll all see each other again sometime.
Thank you all very much for watching.